Greetings, my little triglets. How are you all today? We are going to do section 5.4, which has to do with trig functions of real numbers. Real numbers. Okay, now trig functions are actually cyclical. They go in cycles, and we can measure a lot of things with these trig functions, like your heartbeat or your sleep patterns or the seasons. And they all have predictable cycles. And we use trig functions to represent those cycles. Now the circle we've been using, we've talked about the distance from here to here, or that point being labeled as 1, 0. Now if this is a unit circle, that means that the radius equals 1. So what we're going to talk about here is always going to be on the unit circle where radius is 1. So let's talk about an angle. We have point P here. It's labeled X and Y. And we have an angle. I'm going to use T because in real life things happen in a certain period of time rather than forming an angle. So what we can say then is the cosine of T has to do with the X value, and the sine of T has to do with the Y value. Now that's always been the case. So let's start out with one of our normal points. Say this is -1/2 and √3/2. We have this point out somewhere. Now it's not going to be there. Let's draw a new circle and pretend we know where we're going. Well, if this is 1, this distance here is 1, 1/2 is about here. And then go up until you hit the circle, and we can say that that's -1/2 and √3/2. Because every point that we're going to draw like this is going to hit the circle and form a triangle. So I want to find the other 6, or all the 6 trig functions from just that bit of information. So we can say this is the X, this is the Y. So right away I know that cosine of T is -1/2. I know that the sine of T is √3/2. Those are just from this information. You could probably guess, if you remember from filling in the circle, that this is going to be either a 30 or a 60-degree angle in there, because those are the values that go with it, with 30s and 60s. Now from here, tangent, remember, is sine over cosine. So all I have to do is put √3/2 over 1, -1/2, cancel the 2's, and you get -√3. Now remember, you can only cancel the 2's if they're on the bottom. You may not do it on the top. All right, so that's part's done. Now let's do their reciprocals. Secant of T, flip over the -1/2. Cosecant of T, flip over this and get the radical out of the bottom. So 2√3/3. And then cotangent of T, I'm going to flip this over. So I get 1 over -√3, which is -√3/3. So pretty straightforward. When it's given to you in point form like this, just go ahead and say the X is your cosine, sine is your Y. All right, next thing we're going to talk about is domain and range of our sine and cosine functions. Okay, so domain is any number that can be put in, or put in for t. In other words, it's any length or size of angle. Okay, that's your input. So think about it. If I have sine of t, is there any number that won't make sense there? You can always push sine of some number, any number, and get a value from that. So our domain can go from negative infinity to infinity. I should probably put the proper symbols here. So these mean, if they're curved, that means non-inclusive. If I have brackets, which I will show you in a minute, the range of sine. Now let's think about our sine circle here again. If the radius is 1 on a unit circle, the highest and the lowest that our values are going to go are 1 and -1. Now you might say, well, what about x? Well, x is the input. X can be any angle that you want around here. Okay, so it's not the length on the x-axis. It's what angle or length that you put into this function right here. So our range then is from -1 to 1. Now I'm putting brackets there, mean inclusive. So that means equal to. It can be equal to it. You can't really equal to infinity because you never get there. So that's why we use the curved brackets. All right, another little tidbit you need to know is some functions are even or odd. And there's some that are neither, but not in our trig stuff here. If it's even, that says if you put in -t, the answer doesn't change. Now that's not going to make sense until I actually do a problem, so have a little patience here. Odd means if you put in -t, the answer is the opposite. All right, now let me give you an example. Let's say I have the cosine of 30 degrees. From your circle that you drew, we got that to be √3/2. Now what if I did the cosine of -30 degrees? Well, let's look at a picture here. Here's 30 degrees, here's -30 degrees. Cosine is your x value. If I go this direction, and then I go up to 30 or down to 30, the x part has not changed. It's still going to the right, √3/2. Whether I go up or down is not part of the problem here. It's the x value is the cosine. So I have to think about what's happening with the x value. Well, it's going to the right the same amount, so it's going to be a positive √3/2. So right now, I put in a -30, and the problem didn't change. The answer didn't change. It's still √3/2. So is cosine even, or is it odd? Well, if you look at the directions, if the answer doesn't change, then it's even. So cosine is even. All right, now let's look at sine. Let's do sine of 30. Sine of 30 is this red line right here, the y value. So that's 1/2. Now if I take the sine of -30, I'm actually going down, so that means it's going to be -1/2. It's still a half, the distance is the same, but the direction is down. So here I put a negative in, and I got the opposite answer. So sine is an odd function. Okay, so if you put a negative in and it doesn't change the answer, it's even. If you put a negative in and the answer changes to the opposite, then it's odd. Now back in the day, probably about 10 or 12 years ago, I had a kid named Steven in my class, and somebody yelled out, "Go Steven," for whatever reason, I have no idea. But that gave me an idea of how to remember that cosine is even. I just say, "Go Steven," and it kind of rhymes. Go Steven, cos even. Okay, I know it's a stretch, but that's how I remember it. So if you can come up with your own way, that's great. So if cosine is even, everything else is odd. But a little asterisk here is that the evil twins do what their good twin does. So that means if cosine is even, so is secant. So these two are the only even ones. Everything else is odd. So sine, cosecant, tangent, and cotangent. But if you just remember this phrase that pays right here, go Stephen, then you'll remember that cos is even. Okay. Well, those are my words of wisdom. If you have another way to remember all that, that's great. I'm just giving you my crazy thoughts, because sometimes the crazier the better. All right. Well, Trig loves you still. Don't forget. You need to love it back. Ta-ta for now.